is the second set of domain problems. Again, on the right you see those domain restrictions. The F is for fraction, E is for even root, and N is for negative exponents. So h of x equals the square root of 2x. We're going to go through and see, do we have any of the restrictions? Is x in the bottom of a fraction? No, it's not. Are we taking an even root of x? So the square root is an even root because there's a 2 in here that they don't write for us. So we have a restriction. We have to figure out what can x not be. So what we remember about even roots is that we can only take the even root of positive numbers. So if I look at, we're taking the even root of a 2x. So that 2x, when we multiply those together, has to be positive. It has to be greater than or equal to 0. We can take the square root of 0, so 0 is okay on these. Now 2x is greater than or equal to 0. Again, I can just kind of use this as an equation to solve. So x has to be greater than or equal to 0 divided by 2 is 0. So x has to be greater than or equal to 0. We keep going through. Do we take a negative exponent of x? No. So here's our only restriction. The domain for this one is all real numbers, but x has to be greater than or equal to 0. Alright, our next example, t of x equals 3 over x. We go through. Is x in the bottom of a fraction? Yes, it is. So our entire denominator of x cannot equal 0. So this one's pretty straightforward. We know x can't be 0. Are we taking an even root of x? No. Does x have a negative exponent? No. So we only came up with one restriction on this one. It's all real numbers, but x cannot equal 0. Any other number is okay. So if you notice on that one, we found a restriction right away, but we didn't stop the problem. We still had to look for even roots or negative exponents because sometimes we combine a couple, which is what we're going to come across on this next one. So here's our r of x function, 5 plus x divided by the square root of x plus 3. Here we go through. Is x in the bottom of a fraction? Well, it is in the bottom of a fraction. And are we taking an even root? We are. Is there a negative exponent with x? No. So we have to deal with the bottom of a fraction and the even root. So maybe I'll talk about the even root first, just because I want to. The square root of x plus 3. So what we're taking the square root of, this x plus 3, has to be positive. So we'll say x plus 3 has to be greater than or equal to 0. So what would x be if we subtract 3 from both sides? X has to be greater than or equal to a negative 3. There's one restriction. Now the other restriction that we have to look at is the fact that our denominator cannot equal 0. So if we have the square root of x plus 3, this whole thing cannot equal 0. So mathematically, I could do the opposite of the square root and square both sides. That leaves us with x plus 3 cannot equal 0 squared, which is 0. Subtract 3 from both sides. It's probably getting cut off. And we have x cannot equal a negative 3. So two restrictions, and we have to figure out how to combine these. First we're saying x is greater than or equal to a negative 3, but then we say, but wait a second, x cannot equal that negative 3. So how do we combine these into one statement? We're going to say, well, x has to be greater than a negative 3 then. We'll take off that or equal to part of the statement. So our domain is all real numbers, but x is greater than a negative 3. So there's an example where we have a combination of our restrictions. That one had the fraction and the even root happening.